So I'll go ahead and present today's presenters. A short introduction on who we are and what we do. So myself, I'm Daniel Berezeanu, here to the left. I'm Director of Managed Services at Ready Computing. I'm also ITI Planning Co-Chair on my second term now. And I've previously worked as an implementer for IBM and also an implementer for DTI, a company that created healthcare portals. So I've worked a lot with the IHE standards. David?
Hi, I'm David Pike. I'm the Solutions Consultant with Ready Computing. My background is I'm a member of the IHE IT Infrastructure Committee. I've been working with them for about 6 years. As well, I've helped to work with international projects using ITI profiles, including the Saudi IT infrastructure project for their health IT infrastructure. I'm also currently co-chair of the HL7 Community-Based Collaborative Care Work Group. Karen?
Sure. Hi, this is Karen Whitting. I'm a technical project manager with Ready Computing. I've authored many of the profiles that we'll talk today, specifically XDA and XCPD. I was a co-chair of both the ITI technical and planning committees for a total of 8 years and was on the IHE board for longer than that. Thanks.
Thank you, Karen. Okay, I can't figure out how to switch the slides. There we go. So today's agenda, we will briefly talk about how to benefit from leveraging the IHE standards. Then we'll have Karen present a presentation called Enabling Document Sharing Using IHE. Then we'll talk about Beyond XDS. Then David will talk about the clinical affinity domain decisions, as well as architecture design decisions. And I'll talk about more specifically about the XDS Registry, the XDS source, and consumer. Then we'll summarize some of the benefits of getting involved in IHE, as well as some of the benefits of leveraging these international standards. And at the end, we have a question period, and we'll try to address all the questions that will be appropriate. And so please note your questions or put them in the chat, and we'll hold all the questions until the very end. All right, so IHE is built with modularity in mind, and it leverages an international community of clinical and technological experts and users. On top of that, all our profiles are based on real-world use cases. And we enable flexibility to also address some of your specificities in each one of your projects. So IHE International has also branches for the regionalized IHE, and always allows specificity and additional options that are not in the base standards. What more do we get from using IHE standards? Well, the overall cost of developing the applications and implementing them is lower. Since this is a rather small niche market, then leveraging existing systems from other projects always helps in reducing the risk, the costs. It also helps quickly accelerate projects and make them more accessible to a market so that you don't have to wait until the development cycle happens. It gives you access to existing tools for interoperability, for testing, and for certifications. So again, it reduces costs because you can leverage off-the-shelf products that have been created by vendors and that are leveraged in multiple places in the world, and so the overall cost for each implementation is lowered. Training and deployment skills can be also reused from multiple projects and benefit the wider experience of the community as it is something that's been done elsewhere and don't have to reinvent the wheel at that time. Also, when creating an HIE or an electronic exchange, there'll be a lot of different policies that need to be put in place. And leveraging these standards will also give you a much better framework for creating these standards, these policies across the standards. So again, it helps improve clarity of your project and reduce the costs of maintenance. Again, another benefit is the maintenance of these profiles is also done by the large community, and it doesn't have to be specifically done by experts that you will need to provide. Okay, so an IHE profile-based approach for eHealth project has immediate benefits, midterm benefits, and very long-term benefits. So I'll pass it over to Karen.
Thanks, Daniel. So I'm going to talk about enabling document sharing using IHE next. Next. Okay, so I'm going to first give a brief introduction. Probably the most important part of this is to talk about the principles that underlie all of IHE support for document sharing. I'll give at a very high level a description of the profiles involved, and then three related things as well I'll cover. So next. So this title comes from a white paper that was written quite a few years ago now, published in January 2012. As such, it is slightly out of date, but still the underpinnings of document sharing are unchanged. I wrote this with John Murky. He primarily did the privacy work in that paper, and there's a link to the paper in this chart deck, which hopefully you guys will get. This is a paper that kind of ties all the details of our document sharing together in a high-level overview. And it references things like our additional educational materials and, of course, the technical frameworks, which are on the link that's on the chart. At that link, you can also, there's a link to the white paper there as well. This paper is really good for those who just are starting to do document sharing or those who have done a little bit of it and want to understand kind of the broader perspective of what document sharing is. And as with all IHE content, comments are always welcome, even after 4 years of publication. Next. So let's get into the heart of the subject, which is the principles of the document sharing. So go on. First, I want to talk about the principles that all of IHE operates under. And these are rarely mentioned, but are foundational to all IHE profiles. And I picked kind of the top three here. There are probably more as well. First of all, we describe interactions between systems. We try to, as much as possible, avoid describing internal implementations. So we want to allow flexibility of implementations, but still have interoperability across those implementations. The goal is to support as wide a variety of governance and policy as possible. So we often don't specify governance and policy, but we do say you need to specify it. So we're trying to allow for a variety there, and this is especially true in document sharing. And we also assume there's an understanding of some widely implemented IT standards like XML, TCP, IP, etc. Now, another topic that we will be delving into in more detail in this presentation is governance. As I said, IHE's goal is to support as wide a variety of governance and policy as possible. But we do have to assume there is governance, and especially in document sharing, there is an assumption that there is governance and that that governance is agreed to by the sharing partners. We don't specify the details of exactly what you need to say, but we do list the areas that require decisions to be made. So, for example, it's important to support semantic interoperability. So we will say you have to agree on what format of documents are exchanged, but IHE doesn't tell you what that answer is, just that you should come up with an answer. Also, coding systems, both within the documents and in the metadata. Since there are many coding systems throughout the world, we don't want to tell you which coding system to use, but you should have an agreement with your sharing partners about those. So there will be some more discussion about this later. Dave's going to cover that for us. Next slide. So one of the most fundamental principles in document sharing is that it uses documents. And the most important thing here is we have to define what a document is. So IHE defines a document as something that is content neutral. There is no restrictions on format of the document. A document is, from the IHE profile, document sharing profiles, any collection of bytes that includes proprietary, textual formats, coded formats, whatever format of bytes you want. And all of the IHE profiles operate independent of that format, or, in fact, independent of the information within the documents. But it is expected that each document is a coherent set of healthcare data about a single patient, and it has enough context to be useful to the receiver. So that is an assumption. There are many ways to code a document, and the most common one that's used is either CDA or consolidated CDA. And this is one structure of a document that's very common, but the IHE profiles do not require that. I just kind of touch on the distinction between documents and messages. And again, this is just IHE way of looking at it. Does not mean it's a general term, but it is IHE's assumption within our document sharing profiles. HL7 also describes this, and they have the distinction that I've quoted here. So we basically assume that a document has some properties and is expected to persist for long periods of time. In a way, that's kind of a stable document. It's something that doesn't just get sent from A to B and then thrown away. It's something that is saved persistently over time and are referred back to whenever necessary. So, and it's whole, it has context. That's what we're thinking of as a document. Each document pertains to a single patient. If you combine all those documents together, you have what is in effect a longitudinal patient record. All right, next. So the other key principle within document sharing is metadata. IHE uses metadata to allow for enormous flexibility in the format of a document. So the metadata is the same across all the document sharing profiles. One set of metadata used for a variety of exchange approaches. And that metadata is used to help with identifying the document, finding the document, routing the document, and this list of things here. And I want to kind of talk about electronic preprocessing with a little more detail. So in order to facilitate interoperability, it's important that systems that get documents are able to manage and route and administer and electronically maneuver those documents without having to actually be able to look inside and interpret them. And this is of great value because different systems throughout the world may use different ways of coding things and may have different things inside. But if the metadata is consistent, then any system can be written to adequately process those documents in an electronic manner. So that is why we consider metadata so important. We have metadata about documents that describe what's in the document, what patient's related to. There'll be more detail about that later in the deck. We also have use metadata to describe a collection of documents, a folder or a directory, similar to what you would think of as a directory. We also describe metadata for a submission set that groups all things that were submitted in one time together. And there are also ability to link documents to each other in support of lifecycle events. One of the questions that comes up sometimes in document sharing is, well, how do I find the partner? I want to send this document there. I want to find the document here. I need to talk to someone. How do I find them? And this varies significantly across environments. And so every kind of environment requires a different solution here. So IHE just supports some building blocks, which I've described below. There's kind of two groups of them. One is, let's find an organization I want to share with. And so many places actually just use local configuration files to do that. There's service registries out there, and IHE has a profile called HPD, which also can be used for that. We also have some profiles to find information about a particular patient. So this is, I know what patient I'm looking for. I'm going to go and find out who has information about that patient. Next. I also want to talk about the word community. So in a lot of IHE literature, you'll see the word community used, and it has a specific meaning. And I've put some context. I called it a health document sharing community for the purpose of this slide. And a community is a group of organizations that come together for one purpose, and that is to share health information in support of clinical care. Those communities can be widely different. So some communities come together on a geographical focus. Another example is something like the Veterans Administration in the U.S. Some other affinity. Does not have to be geographical. Communities also can be different structures. Some are very simple, some very complex. And what a community chooses to share could be only summaries or only labs, or could extend to many types of content. So there are many, many varieties of types of communities, but they all have the ultimate goal. And so when I say a community, a lot of people around the world now call that a health information exchange, and that's basically the same concept. So let's just go into the profiles now. Next. So we have three models for sharing documents. One is direct push. This is where I have a document, I'm going to send it directly to the organization that needs it, direct push. Then we have the ability, which now we're talking about a community. I have a community of organizations that are working together, and they've agreed to a common infrastructure, which is where we're going to put and find documents. And then we have a federated approach, which allows documents to be pulled from any kind of a content holder. So on the next slide, I'm going to talk about that in more visual terms. But all of these share the common concept of a document and the common set of definitions. They also share similar governance issues, but there is some differences across them based on the model. So let's go on to the next chart. And here's kind of a visual representation of the different profiles. We have at the bottom XDM. And this is the simplest one, you might think. It is a direct push approach where we generate the content into a file, and then we share that file with the recipient. And this is write once, and it allows for a read multiple times. So there are multiple ways of delivering that file to a recipient. You can deliver it on a USB key or on a drive, or you can send it by email. The next one up is XDR. And here we're sending directly using web services and SOAP. We're sending directly to the recipient. So in order to use XDR, you need to know where the content's going, and you need to have an understanding of the receiver in terms of being able to send it and have them acknowledge that receipt. The next one up is XDS, and this is the one that has the infrastructure. So here, we're within a community where we have a shared set of infrastructure, and sources of content are publishing that content into the infrastructure, and users of content, the consumers, are querying and retrieving that content from our infrastructure. And then we have XCA, which kind of allows to go cross-community. XC stands for cross-community. And so while it really is very general purpose and could go from any content holder, it's kind of designed to allow one community to share information with another community. Okay, so now I'm going to touch on a couple of small topics. First is patient identity management. As I mentioned, each document is associated with one and only one patient. And the metadata describes that patient, either through an identifier and or demographics. In the direct push case, there's kind of two approaches to identifying the patient. You can either make sure that your content contains enough demographic data that the receiver can match, or you can resolve what patient you're talking to a commonly known identifier prior to the push. So in direct push, you have two choices. For all other approaches, the query and the XCA, whoops, thank you, you have only one choice, and that is that it requires you to identify the patient prior to doing the query. So it requires resolution of the patient prior to the query. So the next chart will talk about some of the options that IHE supports. And so we have basically two profiles that allow you to find a commonly accepted identifier. One is PICS and one is PDQ. Let's go on. So the other thing is I talked about searching for information, and this is the HPD profile, which allows a person who wants to share data to find the electronic place to share data. So it supports the ability to communicate both with organizational and individual providers, and provides also contact information for a provider. Okay, next. On. So let's talk briefly about security and privacy. IHE uses a risk assessment and management approach. What this means is, in an IHE profile, first the work is assessed for potential risks. And then those risks are managed through various methods. And so some of the methods are applying a profile, IHE profile, or it could be done through physical environments, through IT approaches, through policy. So it's a combination of all of these things that manage risks. And IHE has many profiles in support of some of these things, and I've listed things like access control, data integrity, digital signatures, etc. So I'm not going to go into detail about those profiles right now, but they do exist. So I'm just now going to do a tiny bit of profiles beyond XDS. So these are the things that have been done that kind of build on XDS. The first of this is OnDemand Documents. As I mentioned before, a document is assumed to be a very static, stable thing. You create a document once, you've saved it, and you reuse it as needed. But there is also a need for someone to access data. Just give me whatever you got. Just give me the most up-to-date information that's available. I don't care about historical documents or what happened in the past. I just want all of the data as up-to-date as possible. And this is what OnDemand is about. So it allows a source of on-demand to register, and it's not actually a document, it's kind of just a false entry. We call it an on-demand document entry. And then a consumer can find that entry, and that allows them to pull the most recent data as a document. So when they retrieve on-demand, they say, give me the most recent information. And every time they retrieve, they could potentially get a different document depending on if the underlying data has changed. And on-demand is also available in XDA as a pull. So just briefly, XDI, which is XDS adapted for imaging. And this allows the imaging sources to publish a set of images. Basically, they publish a document that describes the images. The imaging consumer pulls that document and then is able to get the images directly from the source of the images. And on the last slide, I think this is my last slide, I want to talk about MHD. So MHD is a more recent profile that uses a simple HTTP interface. So all of the profiles we've talked about are based on SOAP. And there are environments, such as mobile devices, which are resource constrained. So MHD's goal is to enable access to documents through those resource constrained systems. It looks basically the same as XDS. You can submit documents, you can find documents and retrieve them. The only difference is that you are using a protocol that's HTTP-based rather than SOAP. And one very important point here, and it's, I believe, my last point, is, again, we're using the same concept of a document and the same set of metadata. So all of these profiles share that same conceptual principles. And that's kind of the point of the paper that I referenced as a starting point. So I believe that's the end of my portion. And I believe I'm turning it over to Dave.
Thank you, Karen.
Thanks, Karen. Okay, my section is talking a little bit about the decisions you're going to have to make when you create an affinity domain for clinical information. Very simply, there's a lot of decisions that have to be made, governance decisions, and I'll go into an example specifically of the vocabulary and terminology management. Go ahead. Okay. When you're setting up a document sharing infrastructure, whether it is XDS or more importantly even XDA, you're going to uncover a lot of governance issues that need to be addressed. Very simply, issues such as who's going to manage the provisioning and capacity of the IT infrastructure. Is it going to be a central group? Is it going to be one of the members? Are they going to be in control? So on and so forth. Often governance becomes part of the organizational dynamics. So a lot of, giving a lot of power to the CIO, giving power to the head of medical information, all get exposed at this point. What happens is that mismatches between what IT needs and what business needs, what the medical community needs, pop up. And over time, the evolution of the governance as the technologies and organizations change need to be addressed and need to be addressed as a group. Now, let's look at, for simple things, such as medical specialties. You have terminology, procedures, standards of case, workflows, on and on, how things are described, how things are dealt with, archived, how they are used, and how they are sent to each other. All must be unified to the best of your ability to make things going. Over time, what you're going to run into is that organizations that were once upon a time independent and had no worries about anybody else have new relationships, new dependencies. What's more, whenever you create something on a national scale, you have legal and regulatory changes that affect individual care providers, affect the communities that are created around the XDS repositories, and this flows through. suddenly it starts changing in all governance organizations. Here's a short list of issues that you can run into. Organizational rules. Within an organization, who's going to be on what committees? Who's going to be in control? How many people are going to do it? Operational rules. How is this going to work? Who is going to be part of the decision-making process for interoperability? Deciding what protocols, what code lists, what interoperability rules will be done. Membership rules, who can join? If you've got a clinic with one physician and one nurse, what standing do they have? Do they have to go through another care provider, such as a hospital, to get in, or do they go directly into it? Connectivity from external systems. This is a big one. When you set these up, you're going to want to look at other things, such as libraries of medical information that may be available. One thing I'll touch on a bit, terminology servers to keep things going. All kinds of external systems are going to touch into this. How is this going to be dealt with? One thing Daniel will touch on a little bit later, system architecture. Can you go back? System architecture, how big, how fast, how powerful, how many servers, how many XDS repositories, all in one, just with one registry with 20 different repositories. All of these are possible, but these are decisions. Terminology and content, one I deal with a lot, patient privacy and consent. How will consent be dealt with? When you go from simply having a patient be told, yes, I want my information to be shared with everyone, down to everybody except Dr. Smith can see this information, that gets complicated. Technical security, bringing in not only encryption, but physical security and all kinds of things that you deal with in a data center. And one of the biggest one, what do you do with the old data? 5, 10, 70-year-old medical records sitting in dusty offices or filing cabinets that need to be brought in so that you have 100% coverage, or 90%, or is 80% good enough? All of these things become real issues when you have to deal with governance. Okay. Let's look at one example. Terminology. Medical terminology varies quite widely between various care providers. In this case, you may want to define general rules and restrictions regarding usage of certain types of data, such as, say, patient demographics. These are big deals because sometimes patient demographics are required. You have to match on them. If I need to find two people with roughly the same name to look up their record, I have to go on which demographics can I have? Can I have their address? Can I have their age? Can I have their marital status? In some jurisdictions, such as Saudi Arabia, you could not ask a woman if they're married. So you can't store that information if they're pregnant. All of these things can be prohibited by jurisdiction, by law, or individual policy within an organization. One of the other problems, contradictions. One organization says, you must do this. The other one says, you must not. These have to be documented. These have to be sent in to the group. Decisions are made on how to handle it so that the implementation rules, when you get started, are clear. It is too late once you have servers up and running to decide that, no, wait, we haven't agreed on this. Okay? Next. Thank you. Okay. In terminology, sometimes it's easy. There are companies that do this. Avalon and Clinical Architecture, two different companies. One does technology mapping and provides terminology servers. Another does terminology management. They work together. They're putting together a nice package. They'll help you work with SNOMED, with all the various different terminologies, local, national, and international, to keep it going. On the flip side, in Australia, the National Clinical Terminology Service developed its own system to handle SNOMED CT, the Australian version, and Australia's own Australian Medicine's terminology. Two various different ends of the spectrum. One very corporate, using, an American style of system where two companies work together, or one very national style where one organization within the government creates the answers. Many EHRs, regional, national HIEs, are integrating these services right in to the HIE, so that the terminology services, when there's a question, go to a third party. They'll go out to a third-party terminology server, an external server, and get the answer. That helps keep terminology consistent across all the care providers in the system. Okay? Okay. There are, of course, multiple clinical terminologies, both proprietary and those based on industry standards. ITSO, SNOMED. For most organizations, it wasn't a big deal when you only had to deal with department level. Didn't have to worry about outside parties. Now, a domain can manage dozens, hundreds of care and IT systems, each with its own clinical terminology, all the data, all the time, all using different systems and disparate terminology sets. By creating a centralized approach, you have an authoritative content database, one database which makes it possible to reduce conflicts. Because when two terms come together, there's somebody to look and go, these two are equivalent, can be referred to a person or a process to eliminate the conflict and make sure the central approach is used. Okay. Terminologies and maps for matching the terminologies, and of course code groups with them, they have to be periodically updated. They have to be new because policies change. New versions of the terminology standards like SNOMED CT are updated all the time. SNOMED is huge and constantly changing. So you have to bring these. In the US, they had ICD-9. They were brought up to ICD-10, which is far more complicated, far more detailed, and forced by regulatory compliance to roll it out by a certain deadline, October 1st, 2015. The panic that ran through so many organizations as they had to not only roll out the technology to handle this much more elaborate code list, but also train people to use it so that the technology could work. Okay. Now, some deployment decisions. Okay. There are several levels. We've already talked to the technology. Karen showed you about XDM, XDR, XDS, and XCA. This puts it on a bit of a more spectrum. You start simply, blind push. Everybody sends everything and doesn't worry about how it gets there. So if you have two clinics working together, they just push information back and forth, and they don't care. And it moves forward, known partners with patient IDs, but the patient IDs may not be the same for both. They're out of band. Again, need to start getting more information back. Where you have, in third stage, known partners, where the patient ID is unified, or at least resolved, but through a process, that's where you get, into real interoperability, where you're starting to make these systems work together effectively. Moves up to the community HIE. The community HIE, where you get groups working together. So you may have multiple repositories working together with a centralized registry. So if someone goes into a hospital in one area, they can go to a different care provider in another area and have the same information available. And then the top level, nationwide health information network, that's when everybody works together. So all the communities work together, go to a national HIE, where that information can be exchanged quickly and efficiently and brought in to alignment with minimum confusion. And as you can see, it goes from push all the way to pull, because when you're getting to the HIE, the nationwide HIE, you can't have everybody pushing information all the way around. The capabilities are there to do it that way, but it makes no sense, because if someone never goes to another care provider, they always go to the same hospital, the same clinician. having their information spread all over the country makes no sense. So it's pull only. You publish the information, and the system goes out and gets it. Next. This is how it maps to IHE profiles. First, secure email. In the U.S., this is known as the Direct Project. This is their way of handling it. It's done through secure email, using a specialized email address used only for the Direct Project. Information is pushed to where it is needed. The next stage of the Direct Project, a little more useful, is using XDM through secure email. That adds the metadata so that the information doesn't have to be pulled from the document itself. It is accompanied and easily found and incorporated system to system. Next way up, we can start getting more into the pull model, where it can be both push and pull. Reliable push with metadata, that's done through XDR, through web services. It's put into the XDS system or the repository style of your choice and pulled as necessary. And it keeps moving. Up to community HID, that's everybody working together. Includes intra-HIE. So you can actually have an HIE where at one level above. And then finally, the national. XCA, where everything is cross-HIE, fundamentally a pull model to bring things from one community down to the one care provider. So everything is available on request. Okay, how is it done? Many use the IHE document sharing system. One of the biggest ones is the US eHealth Exchange, EX, and an XCPD to handle huge inter-HIE. So in the US, you have regional HIEs, then statewide, and then the national, currently called EHEX. The European model is shaping up well. Originally started off called EFSOS, which used all of the XCA. The data was provided through XDR and patient identification through XCPD, cross-community patient discovery. Of course, consent, BPPC, and the IHE profile, which manages simple consent between organizations. This changed to the Expand project as it got bigger and uses more and more information. Next. This map shows a little bit about where in the world is XDS. This was created by one of the members of the committee, of the ITI committee, with a lot of people contributing. And while it is not quite complete, as I don't think anybody's updated in the last 2 years, it does show that all through Europe, North America, and around the world, XDS is in production or in stage. Most of the ones you'll see here that are red says they're in planning, but most of them have actually been executed and are now in at least pilot or in production. Even Hawaii. Anyway, some examples. In Canada, where I live, XDS document sharing framework has a prominent position. In one of the provinces, the subsections of Canada, eHealth Ontario uses an XDS Registry and IHE's Security Audit Repository as part of the Health Information Access Layer. So the documents are being stored in XDS, being secured by ATNA. The U.S. market, in New York, the regional health information organizations are subsets of the state using IHE document sharing and XCA to exchange between the different RIOs. The Alabama State HIE uses IHE document sharing for exchange using XDSB and XDR. And of course, the Saudi Arabian government selected IHE document sharing as the basis of their national infrastructure for all healthcare information exchange. And I think that's it for me.
Thank you, David.
Thank you.
Great introduction to the governance. All right, so I will talk a little bit about the XDS Registry more specifically, and then follow up with the consumer and the source. So the XDS Document Registry is the very central piece of infrastructure that allows all of these exchanges and this interoperability from the different enterprises that will be exchanging systems. So the keynote here is that it is centralized. And with that come certain responsibilities. So functional responsibilities, these are defined from an interoperational perspective by IHE. It's quite simple. It needs to accept the metadata from the repository, store the metadata, and then accept queries about this metadata from the consumers and return the metadata as it was submitted. So pretty simple in theory. But let's look at the metadata. It includes metadata for documents, for submission sets, as a package that kind of surrounds each document or set of documents. So each submission has to have this submission set that encompasses it. We also allow for folders that can be used for grouping documents. It is not a very common use case, but it is available. And the XDS Registry is also responsible for supporting associations. And associations are different types of links that build relationships in between the objects, whether they're folders, documents, or submission sets. Let's look a little bit further into this metadata at the submission set level. There's some attributes that are dedicated to the submission set and must always be present. We're looking at the author. It can be an institution, a person, or speciality, the title of the document, the submission time. The availability status is something that's pretty specific, that it's submitted or approved. There are some coded elements. So the coded elements are what are defined by the nomenclatures that Dave mentioned a little bit earlier. The content type is one of them. We also have identifiers at the submission set level. Patient identifier, source, unique ID, UUID. The document itself also has another set of metadata that needs to match some perspective with the submission set. Patient ID, unique ID. There's some demographics about the patient that are included in the document metadata, but this source patient ID here is simply for knowing that the patient ID when the document was submitted. We also have availability status. We have submitted, approved, and deprecated. So there are a little bit more. So if there's a replacement of document, you have different statuses that can come up. Of course, legal and the author again. There's also a very, very important piece of metadata, which is the repository unique ID, and that is a symbolic link that gives a consumer a way to point back to the repository and do a retrieve of that document. So that's another very important piece of metadata that needs to be counted for by the registry. Of course, there are some more. There's different types of coded values. We're looking at the types of documents, so class codes, type codes, there's event codes, healthcare facility type codes, practice setting types, confidentiality codes. All these need to be agreed upon in the governance piece. When you're creating your clinical affinity domain, you need to sit down with the different establishments that will participate and agree there. The registry can have a role of enforcing some of these and rejecting or not rejecting some of the documents and so forth. So There's also some technical details about the documents. What kind of document is it? What's the MIME type? The format code? Is it using UTF-8? Hash and size, those must match, and then the language. There's associations, so there can be metadata about associations. There's different types of associations, and of course pointers to what are they associating together. Now, the XDS registry has got the basic functions that are mentioned earlier, such as receiving metadata. They can receive single documents, multiple documents at a time in a single submission set, replacing documents, but there are also optional features that can be implemented and very often must be implemented by the central infrastructure. There's offline mode. There are sorry, just mentioned that one. Oh, the XDS registry must manage the life cycle. So if there's addendums or transformations of documents, manage the folders, of course, and there are now updates to metadata so that you can simply update the metadata without necessarily having to resubmit documents. So that are all functions of the XDS registry that need to be developed to support the community needs. What standards are used by the registry? So there's really three categories. So typical electronic business standards such as SOAP and EBXML. And then there's the internet standards that you know, like HL7, HTML, HTTP, ISO, PDF, JPEG, whatnot. And then there's some healthcare-specific content standards such as HL7, SEN, DICOM, and so forth. Now, in terms of non-functional requirements, the XDS registry is a central platform for community exchange, whether it's a couple of hospitals or a nationwide exchange. It is a central piece and it needs to be very reliable. If it breaks down, very often the hospitals cannot function, and you can have a potentially very dangerous situation where the documents are not available, or you're losing documents, and you can face yourself with corruption. So the reliability of this component is very important. Performance is also a very important piece. We'll look at some numbers a little bit later. Scalability. Scalability means that we often start small, but as we move along, we have more and more partners sharing data, and this piece needs to be able to accommodate these growth of volumes over time. How do you scale a centralized piece? What do you need to do at the development level? How does this component manage multi-threads, multi-servers? How does it grow? From a computational standpoint, but also from a data standpoint, from a disk standpoint, and so forth. Availability of that data goes a little bit hand in hand with the reliability, but it needs to be available to the people that want to see it. Otherwise, then you are going to face yourself with adoption problems, with even medical decision problems, and so forth. Backward compatibility. The registry often has to continue evolving and implement the changes in the standard, but often enough it also has to be backward compatible with what has been deployed in the past. So that's a really important piece. You have to keep in mind that whoever builds this needs to continue the evolution, the testing, the certification of the piece, but also support the existing consumers and sources that will be interacting with the registry. All right, so I wanted to quickly just look at some numbers in terms of performance. Let's look at a population of, let's say, 2 million And if half of that population has one visit by year, and for each visit, how many transactions are we looking at to support by the registry? We can look at this schema, which is the basic XDS schema, and we would say, yeah, there's 2 transactions for the patient identity manager. Then the source will do 1 here, and then submitted will have 3 and 4. So we're looking at maybe 4 or 5 transactions for 1 cycle, and we'll have 2 or 3 cycles for 1 visit, right? But in reality, this registry gets deployed in an environment that has many more components that interact with it. So you're probably looking at a sequence diagram that looks more like this, where you've got one consumer here, you've got a provider here, you've got another system there, and then you've got peripheral systems that will either push documents to the repository, pull the documents from, just query to figure out what is in there. And you're looking at a lot more than 4 transactions for a single event. So back to our calculations. So for each visit, 10 registry transactions, it's probably more like 100 registry transactions. We're probably used to seeing these happen from 10 a.m. to 3 p.m. as some of them happen after hours, but most of the day happens in a crunch or a can. And then if we add to this document replacements, document workflows such as in imagery, where you have different steps of the patient has arrived, dictated, prefetching, so forth, the laboratory workflows, we can very easily imagine hundreds of transactions per second on this very central element. So it's one piece that needs to really be taken very seriously in terms of planning and implementation. Let's look at the source and the consumer. The consumer is responsible for querying the registry. There's basically 2 main categories of queries that the consumer can do. It's either a leaf query or God, I forget the term, but you could get a summary of the metadata or the entire list of the metadata. You get the metadata back as a consumer, and you analyze it either with a human interaction or with an automated process. And then you are responsible as a consumer to retrieve the documents that you are interested in displaying. So the document has to keep a link between the repository UUID and the actual URL of the repository where it needs to fetch the document, or the IP address of that repository. The document source is a component that basically has the document and wants to store it. It is responsible of creating the description of that document, so the metadata, and then it submits it to the repository that forwards it to the registry, obviously with the proper patient identifier. Now, in creating and developing consumers and sources, there are many open source frameworks out there. Either they're based on Java or J2EE, or there's also Microsoft projects that are open source. There might be others as well. So it is pretty simple to take either an open source framework or a vendor supported framework. There are many out there. And build a consumer or source to adapt an existing product, or to create one fresh from scratch, or to black box it within an existing product and to interact with an existing XDS infrastructure pretty quickly. One of the accelerators to do that is the IHE Connected On. So the Connected On is an event where vendors get together and complete cross-vendor testing and development in order to attain interoperability. So once you have your prototype, you can prepare for testing accordingly. There's some pre-testing guidance is very important, and lots of available resources to test online and to test before going to Connect-a-thon. And then once you're there, you've got a lot of benefits from testing with at least 3 of your possible vendors that you would be interacting with. And finding a problem at the Connect-a-thon with your code or your implementation can save you a lot of time versus finding that problem very far in the software development chain. If you're already in production or you're just deploying and find out you have an interoperability problem, the cost and the time constraint is going to be much larger than finding that at Connect-a-thon. One other side benefit is establishing relationships with other vendors and building those relationships that you will often have to leverage once you get in the real world and are doing implementations. You've had a chance to actually test with some of these partners that you will be implementing with in the real world. All right, so that was a very short introduction to the registry and the document source and consumer. Obviously, we can go very larger depth into those components and have a much longer discussion about the inner workings of registry, and that would have to be a separate meeting. So I'm just going to remind you some of the IHE profiling cycle. So IHE uses about 18 months from the profile proposition, and from there we get together a group of experts, clinical, technical experts, and we write the profile to have trial implementation, and then we test it at Connect-a-thon, and we try to bring it to final text. So we'll look at this, my next slide, a little bit more. Each domain has an event schedule. We're talking about the IHE ITI domain right now. And I want to remind everyone that there's lots of opportunities for members and even non-IHE members to participate in the planning cycles and the technical cycles. We always need reviewers. We always appreciate change proposals and any sort of participation. So I definitely encourage you. So we usually have IHE call for proposals sometime in September. It's actually closed not too long ago, and now we are doing the profile selection by the committee. We even had a meeting today, and we're meeting next week in Chicago as the ITI International Committee to select the profiles that we'll be describing or implementing in the next cycle. Once we decide on which profiles we're doing, we get together and develop those frameworks or those profiles. We publish them for public comment. So this is when we expect the people that proposed it or the people that are interested by it to read them and provide us input on their understanding and their desires and what we've done. Once we resolve the public comment and we are able to create what we call a trial implementation, and we post it. And this process takes 6 to 13 months. So we post it and we have implementers develop software with it. And that software is then sent at IHE Connect-a-thons. This process can take another 14 to 18 months. So we usually want to have a trial implementation profile in testing for at least 2 years in at least 2 different continents, and with at least, I believe it's 3 different vendors of each. So we want to publish profiles that have products that are backed by it and sufficient testing and sufficient interest. Once it's passed through Connect-a-thon, we do publish a product registry, and we demonstrate also at HIMSS Interoperability Showcase on a yearly basis, which is a very interesting demonstration where you have live interactions and real-time exposition of the different profiles in action. Very interesting. And we also do afterwards the real-world interoperability in clinical settings. As David showed a little bit earlier on where in the world is XDS, it's quite present a little bit everywhere. So IHE improves safety, quality, efficiency in clinical settings. That's our goal. I hope you've enjoyed our presentation, and I'll open it up to questions at this point. Not sure how to unmute everyone.
We have 2 questions in the Q&A, one of which I've answered, and the other perhaps we want to discuss.
Okay. Can you speak?
What's the question?
So it's written in the Q&A, and if you want, I can read it to you. And it says, is there any best practice for architecture design decisions for nationwide XDS infrastructures?
Is there a best practice for it? I don't think anyone has come out with a specific design decision that works best, simply because your country, like every other country, is going to have very specific requirements that can't be echoed easily. The U.S. model of, the state level HIEs connecting to the national health exchange is one model. However, there are countries smaller that use one XDS repository or one XDS registry with multiple repositories for the whole country. It really is impossible to set what a best practice might look like. If you follow the standards, which is, kind of simplifying things, and use exceptions based on your needs is what you're going to see as possibly the best practice. I have seen that done very well in some regions. However, there is no specific document I could point to and say, this is the way you need to do it. Karen, have you seen anything like this?
No.
So I think the short answer is what Karen just said. No, there isn't. The long answer is probably still no.
I think I found out how to unmute everyone. I'm just going to press on the button. I hope it doesn't break anything.
Okay.
One is unmuted. Okay, I found someone that had some feedback and muted only that person.
Okay. So the person that asked the first question, was that a helpful answer?
Yeah, that was helpful. Thank you. About the second question, maybe the question may be simplified into saying there can be 2 approaches in deciding on the architecture design for a nationwide infrastructure. centralized approach or a federated approach. So the balance between those approaches should be decided, I guess. So in that aspect, do you think there can be some specific points that should be taken into account?
Yes. And that is a long, involved conversation. The biggest thing is the number of care providers and the number of patients that are going to be serviced, as well as the information needs on a regular basis. If you are looking at, I'm sorry, I don't know a lot about the Brazilian healthcare infrastructure. I apologize for that. But if you're looking at a population that tends to fit into small zones and not a lot of travel across zones, then a federated model is possibly your best choice, because that will limit the amount of information that has to be exchanged unnecessarily. If you have a population that travels or has needs that will require consultation across community, state boundaries, then you're starting to look at it, but you're going to want to keep the information low. Brazil is a large country, and as such, putting everything in one place may be unnecessary and add complications. I don't know how strong this or the statewide policy and governance is, so that's going to be one of the questions, is how decisions on what can be shared, what needs to be shared, and what should be shared can be made.
Mm-hmm. Thanks, David.
So there's some questions from Raphael. One, is there some relation between XDS and DNA? DNA, if that is vendor neutral archive, I don't think that there is a relationship there. Vendor neutral archive is generally an imaging archive that allows different modalities to submit their images there, and does allow some XDS as well, transactionally speaking. But it wouldn't be a XDS registry; it would be more of a source or consumer. Then medical images and reports can be managed by XDS? Definitely. XDSI provides both ways. You can manage images using XDSI with the two-tiered workflow that Karen highlighted earlier, where you retrieve metadata about the images in a manifest, and then with the manifest, you go and get the actual image using a DICOM transaction. You can manage reports either directly via XDS, or you can keep that two-step workflow where you first retrieve the metadata, then retrieve the manifest, and with the manifest retrieve the report. So both can be achieved. Is there some open implementations using XDS standard? There are a couple, and I really like to dissociate the registry from the consumer and the source. So typically there's the source and consumer are connectors where you can use something like OHT to open health tools and easily have access to the transactions and simply send or retrieve metadata or documents using those. There are, I believe, XDS Registry implementations that are open source. I think it's called OpenEHR. That is also available. I've got no experience with it. Well, Question number 4 is, why isn't there any XDS ongoing in Brazil? I really don't know if there is or isn't any XDS in Brazil, but one of the prerequisites for XDS is really to have patient identity management done prior to start doing XDS. If you cannot solve the patient unique identification problem, you will not be able to go to XDS. So that's really the first problem that needs to be tackled. How are you going to identify patients uniquely? There's more questions. Is it possible to participate as a Connectathon tester? Where are the rules? Karen, do you know that?
In terms of, and I just need to understand what we think a Connectathon tester is, and I guess I'll go into the 2 roles that you can go to a Connectathon as. One role is as a system implementer that brings a system there to be tested, and anyone who implements a system can do that. The other role is as a moderator. And there are rules on who can be a moderator, and those people are trained by IHE staff to moderate the test and verify the test. And so if it's a moderator, the rules are that you, I believe, have to have no financial interest in the outcome or any system that's that could be there. So the specific details are on the HIM site if you want to understand about being a moderator. So I can see some questions that, Daniel, you can't see, which seems weird. So the first one was, where does the binary data or files that the metadata part describe ideally belong to? The question, XDS repository, or can they stay on XDS source part? And I answered that in that documents are saved in what XDS calls the repository, but that repository can be anywhere. You can have multiple repositories for every XDS infrastructure, and you can actually group a repository and source together so that conceptually you could have it stay with the source. So I answered that one. And I see another one, which is the most common way to implement a document repository? It seems that the use of a type of document database, NoSQL, or a directory service. What countries generally use? I don't know the answer. Daniel or David, do one of you know the answer to that?
So for a document repository?
Yes. So
often enough, the document repositories are pieces of the infrastructure or of the software that creates the documents. But there are other vendors, such as OnBase, that are strictly a document repository. And I've got no clue what database they use underneath, if they use any. In my previous life, I implemented a XDS repository, and it had support for multiple types of persistence. So you could either save the documents directly to file or save them in a database as a blob. And the database supported were Oracle, DB2, and Cache. So I hope that kind of helps.
Yeah, I think the short answer is it is very implementation dependent, depending on who the supplier is. A NoSQL database is used for many. IntraSystems HealthShare, which is an IHE software, uses a version of NoSQL, their Cache database, which is originally developed on months, but is a not NoSQL, but somewhat equivalent. IBM's offering uses a directory service. I believe that's what is currently being used in Saudi Arabia in their design. It's very implementation dependent. There is no best way because everything has its values, and the back end is not one of the strongest requirements of design because once you set it up as an XDS repository, how the transactions work on the back end are largely transparent.
Yeah, and
that wasn't a short answer.
I would add that the repository really isn't a very difficult component to implement if you're doing it with a database or to disk. The registry, though, will be much more complicated and complex, and there you'll have to leverage a database and some heavy architecture around that.
So I see one more question, and that question says, here in Brazil, we are testing a model of exchanging information using XDS plus OpenEHR, seeking a more reusable template. I'd like to hear them about this proposal.
So I don't know if you could elaborate a little bit on your question, Rodrigo, in terms of the reusability.
Okay, we use the OpenAir inside the metadata to transport a data into the XDS, mainly for using the archetypes to structure the information and transport this. And the first step, we try transport a little model, and the next steps we try to make the change in the archetype and compositions and exchange the more information in the same model. So is okay?
Okay, so are you using the XDS standard with OpenEHR?
XDS? Sorry, I don't understand.
So the template piece, is that really like on the content of what you're exchanging? Is that more of a CCD template?
Yes, more or less, yes.
Rodrigo, I think that's a very, very tight implementation question, and it would be very difficult for us without knowing a lot more background about what you're trying to accomplish. I don't think we can answer that question usefully at this presentation. Is there more questions?
XDSI can be used as part of an image manager. Archive implementation. Definitely. Yes, XDSI can be used as part of an image manager / archive implementation. Yes, absolutely.
That's what it's for.
All right. So we are at 8:30 right now, my time. So we want to thank everyone for joining, and wish you a pleasant end of evening.